An interstellar visitor is heading straight for Jupiter's Hill radius, the exact spot where Jupiter's gravity takes over from the Sun. The perfect parking zone for probes. On October 30th, NASA's data showed 3 I/ATLAS would arrive within this radius on March 16th, 2026. Then Avi Loeb noticed this impossible coincidence and emailed NASA. Within days, NASA suddenly revised their numbers, now placing it just outside. Timing? Suspicious. Let's dive right in. So what exactly is Jupiter's Hill radius, and why should anyone care? Think of it as an invisible boundary around Jupiter, 53.5 million kilometers from its center, where Jupiter's gravity becomes stronger than the Sun's. Cross that line inward and you're in Jupiter's world. Stay outside and the Sun keeps pulling you away. This isn't just some random astronomical trivia. These gravitational balance points are incredibly valuable real estate in space. NASA parks satellites at them all the time because they require almost no fuel to stay put. The James Webb Telescope, sitting at one right now, 1.5 million kilometers from Earth, quietly observing the universe. These spots are so useful that mission planners specifically target them when designing long-term space missions. Now imagine an object that's been drifting through interstellar space for potentially millions of years, never influenced by our solar system until recently. The odds of it naturally arriving at this precise location around Jupiter. We're talking about hitting a cosmic bullseye from across the galaxy. On October 30th, NASA's JPL Horizons database showed 3 I/ATLAS would reach its closest point to Jupiter at 53.445 million kilometers, with a margin of error of just 0.06 million. Jupiter's Hill radius, 53.502 million kilometers. The numbers were practically identical. Not close, statistically indistinguishable. Avi Loeb saw these figures and did what any scientist would do. He reached out. On March 16th, he sent an email to David Farnokia at NASA's Jet Propulsion Laboratory, simply noting this remarkable alignment. Not making accusations, just pointing out something that seemed worth discussing. The response? Nothing. No reply, no acknowledgement. But something did happen. Within days of that email, NASA's database started changing. They revised 3 I/ATLAS's non-gravitational acceleration, essentially forces pushing it beyond just gravity. The first revision reduced it by a factor of 4. Then, right after Loeb's email, another adjustment dropped it by a factor of 6 more, down to 6.8 times 10 to the -8th astronomical units per day squared. The new projected distance to Jupiter? 53.587 million kilometers. Just outside the Hill radius. Problem solved, right? Here's what troubles me about this. These aren't small tweaks. We're talking about massive revisions to fundamental calculations. How does an organization with NASA's resources and expertise miscalculate by these margins, then conveniently land on numbers that place an object just beyond a strategically significant boundary? And why the complete silence to a legitimate scientific inquiry? Look, I want to be clear here. I'm not saying NASA is definitely covering something up, but the timing is impossible to ignore, and it raises questions that deserve answers. What makes this even more compelling is that 3 I/ATLAS isn't just following an unusual path. The object itself behaves in ways that challenge everything we know about comets. And we need to talk about what it's actually doing out there. Every comet we've ever studied has a tail. That's basic astronomy. Solar wind and radiation push gas and dust away from the Sun, creating those beautiful streaming tails that have captivated humans for thousands of years. The rule is simple. Tails always point away from the Sun. No exceptions. Except 3I/ATLAS has a 1,000,000-kilometer tail pointing directly toward the sun. And before anyone suggests it's an optical trick, it's not. Sometimes when Earth crosses a comet's orbit, we see leftover dust ahead of it from our viewing angle, which can create the illusion of an anti-tail. But we're not crossing 3I/ATLAS's path. The geometry doesn't work for that explanation. This anti-tail is physically real. The physics behind this should be impossible. At 3I/ATLAS's distance, solar wind screams outward at 400 kilometers per second. Natural gas escaping from a sun-heated comet, about 400 meters per second. That's 1,000 times slower. Let me put that in perspective. Trying to push gas toward the sun against that solar wind is like trying to run forward at 10 kilometers per hour while facing a 10,000 kilometer per hour hurricane. You wouldn't just fail, you'd be obliterated instantly. Yet somehow 3I/ATLAS is maintaining a structured, organized stream of material flowing toward the sun for over 1,000,000 kilometers. For this to work, the density of that anti-tail would need to be roughly 1,000,000 times greater than the solar wind itself. The mass loss rate? About 200 metric tons every single second. Over just October and November, that's several billion tons expelled, approximately 10% of the object's estimated minimum mass. But here's where the numbers stop making sense. During its closest approach to the sun on October 29th, 3I/ATLAS also showed measurable non-gravitational acceleration. For a natural comet, generating that level of thrust requires expelling more than 10% of its total mass as gas. So we've already accounted for 10% mass loss just from the tails. Now we need another 10% for the acceleration. That's 20% of the entire object gone in 2 months. Either 3I/ATLAS started significantly larger than any observations suggest, or something else is creating that thrust with far greater efficiency than thermal outgassing. And then there are those jets. Watching the images from amateur astronomers, and by the way, the quality of their work puts some professional equipment to shame, you can see these highly focused beams shooting toward the sun. They're not diffuse or scattered, they're organized, columnated, laser-like, and they maintain that structure for days without breaking up. 3I/ATLAS rotates every 16 hours. If these jets came from multiple vents on its surface, like we see on normal comets, they'd spray outward as the object spins. Think of a rotating sprinkler, but that's not what we're observing. The jets stay coherent and directed, as if they're coming from a fixed source. The only way a natural comet could do this is if it had one single vent that only fires when facing the sun during rotation. But then, we'd see pulsing, jets on, jets off, jets on, jets off, every 16 hours like a heartbeat. We don't see that. The jets flow continuously, as if the source isn't rotating at all, except the object definitely is rotating. There's another detail that doesn't fit. 3I/ATLAS's brightness changes by 10 to 20% with each rotation cycle. According to NASA's own assessment, the vast majority of its brightness comes from the coma, that cloud of gas surrounding the nucleus, not the solid nucleus itself. But here's the thing. A coma doesn't rotate with the nucleus. It's just gas floating around the object. So why would rotation change the brightness? The nucleus is too small and has nowhere near enough gravity to drag its gas cloud along as it spins. Yet we have clear photographic sequences from observers showing the brightness and gas patterns shifting in sync with the rotation. Amateur astronomer Ray's astrophotography has captured some stunning images of this. You can literally watch the brightness pulse with the rotation. That shouldn't be possible with a natural comet. The physics don't support it. This is where the artificial propulsion hypothesis starts making uncomfortable sense. Natural cometary outgassing moves at 400 meters per second. A chemical rocket, 4,500 meters per second, more than 10 times faster. Ion thrusters operate at even higher velocities. When you can accelerate material that much faster, you need far less mass to generate the same thrust. Suddenly, the math works. The 10% mass loss problem resolves itself. The anti-tail's seemingly impossible density can be explained by directed propulsion rather than random thermal outgassing. The continuous non-pulsing jets make sense if they're not tied to surface vents, opening and closing with rotation. Avi Loeb didn't just throw this idea out casually. He compiled detailed analysis, ran the calculations, and submitted papers to scientific journals for peer review. Not blog posts or press releases. Formal academic papers with testable hypotheses and mathematical evidence. Every major journal rejected them, not after peer review, not after finding flaws in the methodology. They simply refused to even send them out for review, as if the hypothesis itself was too controversial to consider. That bothers me deeply. Science advances by examining uncomfortable possibilities, not by rejecting them out of hand because they challenge our assumptions. If the math is wrong, prove it wrong. If the evidence doesn't support the conclusion, show why. But refusing to even look at it, that's not science. In 18 days, we're going to get our best look yet at 3 I/ATLAS. It'll be more than twice as close to Earth as when Hubble captured that now famous image. Every major telescope, Hubble, James Webb, ground-based observatories, will be pointed at this object. We'll see it from a completely different angle with unprecedented detail. The interesting thing is, theoretically, it should be getting dimmer and less active right now. It passed its closest point to the Sun almost a month ago and has been moving away since. Less solar heating means less sublimation, less gas production, less brightness. That's how comets work. But when we first spotted 3 I/ATLAS back in July, it was quite far from the Sun and still remarkably bright with obvious features. Now that we're getting this close with superior observation angles, we might see details that are difficult to explain away. And in March 2026, we'll have the moment of truth about that Jupiter encounter. Spacecraft like Juno orbiting Jupiter, the JUICE probe, and 16 Psyche will provide precise astrometric data. Not projections or models, actual measurements of where 3 I/ATLAS passes relative to Jupiter. If it crosses inside that Hill radius, despite NASA's revised numbers placing it just outside, that's going to be hard to dismiss as calculation error. The real trajectory doesn't care about database updates or revised projections. It just is what it is. What strikes me most about this entire situation isn't any single anomaly. It's the pattern. An interstellar object exhibiting behavior that defies conventional comet physics should be generating enormous scientific excitement. Even if NASA remained convinced it's entirely natural, this would still be groundbreaking. A completely new type of comet, unprecedented outgassing mechanisms, revolutionary insights into how interstellar objects behave. But instead, we get not much, sparse coverage, minimal official discussion. The anti-tail that shouldn't exist gets barely a mention. The impossible mass loss rates, hardly addressed. The Hill radius trajectory that Loeb calculated down to statistical precision, revised away with no explanation. And when one of the world's most respected astrophysicists raises these concerns directly with NASA, the response is silence, followed by convenient data adjustments. I'm not claiming to have all the answers here. I'm asking questions that I think deserve answers. Questions that any curious person following this story should be asking. Because whether 3I/ATLAS is a bizarre natural phenomenon or something more, it represents one of the most scientifically significant objects to pass through our solar system in our lifetime. And it deserves transparent, rigorous investigation, not silence and unexplained revisions. So here's the bottom line. An interstellar object is heading to Jupiter's Hill radius, a location so strategically valuable that we use similar points to park our own spacecraft. The numbers showed a perfect match. Avi Loeb noticed and contacted NASA. Days later, NASA revised their calculations without explanation, placing it just outside that radius. Either this is the most unfortunate series of calculation errors in recent NASA history, or something else is happening. The good news: we don't need to speculate forever. In 18 days, our best telescopes get their closest view yet. In March 2026, spacecraft near Jupiter will measure the exact distance. Not models, not projections. Hard data that can't be revised away. Whatever 3I/ATLAS turns out to be, we're documenting every development right here on Galactic Breaking News. Here's what I need from you. Hit that like button right now. It helps more people see this story. Drop a comment below with your honest take on NASA's number changes. Subscribe to Galactic Breaking News and turn on notifications so you don't miss our coverage when those telescopes start delivering new images in 18 days. The countdown has started. The data is coming, and we'll be here to break it down for you. This story isn't over. It's just getting started.